Next speaker represents Aker Carbon Capture, one of the major carbon capture technology companies involved in many CCS projects with industry frontrunners. Aker Carbon Capture is also the main sponsor making this conference possible. The CTO of Aker Carbon Capture has been invited to tell us how the industry frontrunner Aker is answering to the climate challenge we face. Please welcome Jim Stian Olsen.
I hope you can hear me now, and I hope the production will let me know if there is a problem with my sound. So I'll talk about how we are looking at this road to net zero and try to provide an industrial perspective to that. And first, I wanted to start with this number, and I think this is not an unknown number to this audience. It represents the CO2 emissions every year that we have right now. And it also represents the challenge that we're facing when we want to get to net zero by 2050. The CO2 emissions that we see, it's distributed among several segments, and power and heat generation is, of course, the most important one, with close to 50% of the responsible for close to 50% of the emissions. And then we have the industries such as cement industry, steel mill, process industry, and so forth, for standing for about 20%, and transportation is 25%, while building and others are at 10%. And each of these segments have various measures that needs to be taken in order to solve this problem. Often it's focusing on energy optimization in certain segments. We need to deploy a lot of renewable energy, and of course, if we're going to solve the issues with transportation, we need some very innovative solutions in order to get to net zero for that segment. And what we want to achieve is to go from 37 billion tons of CO2 down to zero. And so, when I think about this, it's an abstract number, and it's difficult to understand exactly what is needed to get there and what exactly it means. And we see that it's important for us to set the right pathway to get there. And there's been written a lot of reports on this, various roadmaps to get to net zero from both IEA and IPCC and so forth. I'm not going to dwell too much on that, but I wanted to just highlight some aspects here in order to set the stage a little bit of how are we going to get there. And if you look at the projection that are made by IEA and their report Net Zero by 2050, they say that in order for us to achieve that goal, we need to, by 2030, which is 8 years from now, have to deploy 630 gigawatts of solar. We need to deploy 390 gigawatts of wind power. And there's been an accelerated deployment of that over the last couple of years. So there's probably a chance that we will reach that goal. But then if we look at carbon capture, utilization, and storage, today we have deployed approximately 40 million tons of carbon capture and storage globally. And we need to be at more than 1,600 million tons CO2 capacity by 2030. We are currently building the world's first capture plant at the cement factory at Brevik here in Norway. That has a capacity of 400,000 tons. So to achieve this, it means we have to build approximately 4,000 Brevik CCS projects globally by 2030. And when I think about that number, I think it's a bit overwhelming sometimes, and I'm wondering how are we going to achieve that? Sometimes it's good to take a look at history and what has been done before. In this picture, you see the B-24 Liberator, which is an airplane that was built during the Second World War by the American armed forces, and it's a symbol of one of the important tools to for them to be successful in a crisis situation. But what I wanted to talk about here is the deployment or the effort that the Americans did in order to overcome the challenge that they had during World War II. So they initiated a massive focus on building equipment to serve their purpose during World War II. And they built, during the course of the war, 17 aircraft carriers. They had 297,000 planes were built. They had 85,000 tanks, and more than 2 million army trucks were built over a very short amount of time. This airplane has more than 1.5 million parts, but at the height of the production of this plane, Lockheed Martin produced one plane every 63 minutes in order to deploy fast enough. So it just shows that if you decide to focus enough, it's definitely possible to achieve things that seem impossible. So maybe we can learn a little bit on this of this effort when we're going to deploy deploy our carbon capture and storage projects over the next 8 years. Then what do we see in terms of incentives to get there, and what do we need to get there? Of course, there's a lot of talk about the carbon price is needed to achieve this, and we see that it's moving in the right direction. It's gone up from around between 20 and 30 euros since early 2021 to 85 euros per ton now. And of course, this helps a lot. And then we also see that the capital is moving in the right direction. An example of this is the Glasgow Financial Alliance, which during COP26 committed to be net zero by 2050. And they represent close to 130 trillion euros of capital. Of course, if this starts to move in the direction of decarbonization, that could be a huge strength and much needed effort in order to achieve our goals. Aker Carbon Capture is part of Aker Horizons, and Aker Horizons is the portfolio company that owns renewable companies with renewable solutions and also green technology, and they're also part of this Glasgow Alliance, and have committed to reduce be net zero by 2050, and we think that together with them, we will be able to accelerate this deployment significantly, and I think it's possible for us to contribute positively in that sense. So we've already taken some steps in Aker Carbon Capture. We're a technology company first and foremost, and we started our journey back in 2008 when we developed our technology through the Solvit project, and we also built the Mongstad Technology Center. And since we finished the Technology Center Mongstad, we haven't been resting. With smart engineering and clever solutions, we've been able to reduce both the cost and the footprint of our technology by 90%, and we now can deliver better capture performance with our Just Catch 100, and this is a plant that is ideal for medium-sized emitters, and it's also can achieve high capture rates, more than 90 to 95% on various flue gases. And of course, this product is also the basis of our newest innovation, which is not a technology innovation, but it's a commercial innovation. It's carbon capture as a service. We found that the CCS market is not moving fast enough, so we deployed or launched carbon capture as a service as an offering in order for us to accelerate the CCS market. And the general idea with this offering is that we take the complex management from a full CCS value chain and offer our customers to help them with the entire development of this. So we take responsibility for the financing part, we take responsibility for the carbon capture part, including the conditioning of the CO2. And then through partnerships, we will also engage in take care of the transportation and the permanent storage. And in this way, we believe that we can help our customers come faster to decarbonization through CCS. And some of our customers are very knowledgeable and spend a lot of resources to understand how they can best design a CCS solution for themselves. But also, many of our customers are also don't have the resources to do this, and therefore they're very appreciative if someone can handle the entire thing for them as a one-stop shop. And this is what we're trying to achieve with carbon capture as a service. And of course, I am the CTO of Aker Carbon Capture, so I'm responsible for the technology in the company. And we see that in order for us to achieve the goals that we have, we need to work together with other technology companies in order to succeed. We work very closely with, for example, Aker Solutions, and we utilize their engineering and project execution capabilities to deliver the large projects like we're doing at Brevik CCS. We work with companies like Hitachi Zosen INOVA, Haldor Topsoe, MAN Energy, and Siemens Energy, which have technologies that are complementary to ours, so that we can develop good offerings across the entire value chain of technology suites needed to realize the CCS project. We work with Sintef, and we've done that for many years to develop our technology, and we will continue to collaborate with them in order for us to improve on our technology, but also to develop new technology going forward. Carbfix is a company, an Icelandic company, that has developed a unique technology to store CO2 underground through mineralization. And we truly believe that together with them, we can accelerate the CCS market by combining our complementary technologies. And in a fast-changing world, we see that digital solutions is becoming even more important. So we've partnered with Microsoft, Cognite, and ACE in order to build good technical solutions, digital solutions, and leverage the data to improve our company. And then just recently, we joined the Texas Carbon Management Program, which is hosted by the University of Texas, Austin, and we'll work together with them on research and development within post-combustion carbon capture. We really believe that we need to become better all the time, and that's why we've established a technology strategy funded on the principles of strengthen, expand, and explore. We need to always strengthen our core technology and improve that so that we can stay ahead of the curve at all times. In addition to that, we need to look for new technologies that allows us to capture opportunities in adjacent markets. And we are looking into new technologies today, and we're looking forward to developing that further into commercial offerings as well. And of course, we need to be curious, and we need to explore on the fringes of what technology can offer. And we need to explore nascent technologies that we can mature into industrial offerings, just like we did with our post-combustion capture technology when we took it from the lab and out into industrial application in for example, the Brevik CCS project. And then what we have seen, just to share a little bit about how we work with technology development and what we've achieved since we started back in Aker Carbon Capture back in 2020. We've seen over the last couple of years there's been a shift in the demand and the requests from the market. Back in 2008, when we started out with developing our technology, there was a consensus that 85% capture rate was a good target to aim for when developing carbon capture plants. Over the last couple of years, there's been an increased focus on very high capture rates, 95% or higher. And of course, in order for us to meet this demand, we have executed research and development projects in order to meet that. And we did a project at Tilla together with Sintef last year, where we did testing of our technology on low CO2 concentrations. And we see that we relatively comfortably can achieve 95% capture rate or higher using our technology even on low CO2 concentrations, which we know is a challenge. We also executed a mobile testing unit campaign together with Preem last year and in 2020. And there we verified our capture technology on hydrogen production, also there achieving 95% CO2 capture rate, and we had more than 3,000 operating hours in total during that campaign. So it was a really good project for us, and it just shows that we work hard to not only develop new technology, but also to push the limits of the technology that we've already developed. And then, in order to stay in front, we need to be agile. And we believe that use of data is an enabler for increased performance and rapid innovation. And in order to achieve that, we need to make good use of all available tools. And we have then teamed up with our partners in order to build a digital ecosystem for carbon capture. And this ecosystem has 3 layers that we are focusing on. Of course, starting from the left on this figure, we have the data layer, and this is where we collect all the data from, such as operational data, engineering data, document management data, and so forth. The second layer is the platform layer, and this is the layer where we make sense of our data. So we spend time here to contextualize and structure the data so that they will be easily available for our users. So, for example, our future digital twin will reside within this platform layer and then allow our engineers to extract data and information from that and use that to improve both the performance and operations of the plant. And then, of course, we have the application layer. And this is where we add applications that are connected to the data layer. We're already today doing remote monitoring of our mobile testing unit through this system, and our MTU operators can easily follow the operations of the mobile testing unit on their mobile phones. And this we will expand into remote control, and then as we mature this further, we will start to use advanced data analytics to ensure that we both increase the performance and also operate our plants more efficiently when they are available. And what we are trying to achieve here is to have data-driven learning at all times so that we can make sure that we're always performing at our best and that we find the best solutions going forward. We also believe that using data in this way will lead to an increased speed when it comes to innovation and development. So I think I'm getting close to the end of my presentation here. So just to summarize a little bit, what is the focus for us when it comes to achieving or supporting the road to net zero? We are focusing on cost reduction. It's going to be a very important task for us as a company, but also for the whole CCS industry. The cost needs to come down, and we're taking active steps both in the way we execute projects, but also in the way we develop our technology to achieve that. There has to be a change, or increased pace of change in the industry. We need to allow ourselves to more rapidly deploy CCS projects. We need to develop faster in order to meet the requirements that are facing us. And then we also need to have innovation in all segments. It's easy to think about innovation as something that happens in the technology segment, but what we see is that we need to really have innovation in the commercial models that we have, in the regulatory practices, and on all parts of this needs to think in new ways in order for us to succeed to meet the goal of net zero by 2050. I think I'll stop there and I'll take your questions if you have any.
Thank you very much, Jim Stian. We have indeed received some interesting questions, but due to time constraints, I ask you to kindly post those questions in the comment chat, and hopefully Jim Stian will log on to tap in and answer them written. Okay, thank you very much, Jim Stian.
Thank you.